Now we are discussing the universal law of gravitation. The Newton, he was thinking what was the reason for the falling of an apple from a tree. While he was thinking to give the answer for that question, he came up with universal law of gravitation. This universal law of gravitation, it not only explained the reason for which the Newton was thinking why the apple was falling from the tree, but it is also explained the terrestrial gravitation, means what is the reason for the planet's movement, why the planets are revolving around the stars, why the earth is revolving around the sun, why the moon is revolving around the earth. The universal law of gravitation gave the answer for this question, and it also gave the answer for the Kepler's laws. Newton mentioned that the moon is revolving in an orbit with a radius rm around the earth. The moon is revolving around the earth because of the centripetal force, which we are now calling as a gravitational force, and the centripetal acceleration due to earth's gravity of magnitude is given by am is equal to v square by rm, where v is the speed of the moon and rm is the radius of the orbit we have discussed just now. This is equal to 4 pi square rm by t square, where t is the time period, means the time taken by the moon to complete one revolution. It is approximately 27.3 days, and rm is nothing but 3.84 into 10 to the power 8. If we substitute these, then we will get the acceleration due to gravity, acceleration due to Earth's gravity. So the answer is 9.8 meter per second square. So if an object is falling from the first floor or second floor or from 10th floor towards the earth, it is falling with an acceleration due to gravity 9.8 meters per second square. So every object, it is being attracted by the earth with an acceleration due to gravity 9.8 meter per second square. Now we are explaining the gravitation force. The gravitation force equation F is equal to G into m1 m2 by r square, where capital G is the gravitation constant, which we are also calling as universal gravitation constant because it applicable everywhere in this universe. M1 and M2 are the masses of the two objects between if we take an object, this is object 1 and object 2. If we are finding the gravitation force between these two objects, then the mass of the object 1 is m1 and the mass of the object 2 is m2, and the distance between these two objects is r. So the gravitation force is inversely proportional to the square of the distance between these two objects. Means the more the distance between these two objects, the less is the gravitation force. So if we take the sun's gravitation force on the earth is high compared to the sun's gravitation force on the Saturn, because the distance from the sun is more in the case of the Saturn, where it is less in the case of the earth. So the gravitation force, it depends on the distance between the two objects in between which we are trying to find out the gravitation force.